Alright, I'm assuming this is recording. Yeah, I think it is. Okay. So, the priority of what we're doing today is going from Lafayette to New York. You're trying to communicate from one PC, let's say this PC in Lafayette, to this PC in New York. Let's just say you got a really bad bitch waiting for you in New York. Alright, so you already have this done, so what we're going to do is we're just going to go ping. I already know the IP, but let's look, double check, 202.2.2.11. See, we're getting replies, that means we have connection, everything's good to go. So let's move away from that and go ahead and make a new thing. I haven't made any changes. So if I make mistakes or run into any hiccups, it's because I'm preparing this again completely from scratch. We're going to start with 3 routers. Now, how you want to do it really just depends on you. I think it's wise to try to set up the routers first, but we're going to go ahead and put all the devices out so we see what we're working with. We got a couple of PCs, we know that. Not a server, a switch. Oops. Now, something that Sharif doesn't show that I'm going to do right now is actually, we're going to delete these. And why we're going to do that is because we can go ahead, we need serial connection, so we're going to add this. Power it back on. And what we can do is we can go ahead and just copy that router and then paste it. Now you don't have to configure those, I already have it. Another thing, this is just personal preference, but I'm going to go ahead and label mine before I even change the host name. So we got ISP Lafayette, and we got New York. So now that that's all done, pull these in a little bit closer. Alright, I don't know about your learning style, but I like notations. Notations always help me. So we're going to label this. We know that this is going to be our Lafayette network. This router is for this. In fact, let's drag this and make this a little bit more obvious. ISP is going to be in the middle. New York's by its network. So we need to give these networks IP addresses. It really doesn't matter what you want to name it. So let's go against the example and do 10.1.1.0. Saturday notation 24, that's important. For the WAN IP, let's do 45.21 and go with 0 here. That's going to be out of, oops. Saturday notation's got to be noted. Make sure you do that so you know your subnet mask. For these, there are only going to be 3 available IPs, so you need Saturday notation 24. Always, yeah, I had to look it up. Leave it. So, oops. Always keep that in mind. So we got minus 24. That's going to be U0. Minus 30 is only 3 IP addresses. I actually got them reversed. Nope, I had it right the first time. Okay. My apologies. 24. I'm going to go with 30. So always just double check yourself. It's worth the extra 2 seconds. Since we went with 45.21 and 0, that leaves 0, 1, 2, and 3. We're going to have to start with 4. 45, 20, 1, and 4 out of 30. Now, let's give our New York LAN a different IP. We can go with 16.20.14.0 out of 24. All right, now we can start making connections for the switches and the PCs. Obviously, you're going to just be doing copper straight through. The old command, you can just keep doing it. Doesn't really matter. I'm just going to go with fast Ethernet because that's what's available on these. All right. Now, same thing from the switches to the routers. Now, you can pause right here and set up the configuration on for your routers and this local network. So we're going to drag just to see a little bit. Let's go ahead. Actually, I went against what I said. We're going to do the serial DCE. Serial to serial. And we're going to go serial to serial. Oops. If I could stop misclicking, that'd be great. All right. Once again, let's drag things out. Make it easier to see what's connected to what. So for this router, first thing we're going to do, pop into the CLI. We're going to enable, and we're going to go conft, of course, host name. This one's, we already labeled it New York, so we know this is New York. We're going to go clock rate, because we want to have a consistent clock rate. You go with the standard 64,000. My apologies, that's for later. Anyway, so we're already in conft. We're going to go interface G, finish it 0/0. Now we need to assign the IP address. So we're going to give it an address. This interface is obviously going to be the one that's to our right, 16.20. There's a cat, sorry. 14.1. And the reason why we're assigning it 1 is because this interface for this router, the router is the default gateway like at your house. It's going to always end with 1. It's like the first device on the network. And considering we're using 24 notation, it's always going to be 255, 255, 2550. So we knock that out. Do we no shut? You see that comes up. Do. All right. So that has gotten this set up so far. Before we get ahead of ourselves, let's do the same thing on the Lafayette one. CLI. Enable host name. Oh. Alright, same thing with this one. Our local network is 10.1.1.0, so this is going to be, got to go into the interface first. Forgive my mistakes. Okay. Now these are set up. What you can do is you make sure your computers are actually configured right. Now that we know what the IP address is, let's go ahead and label these before. Let's give them IP addresses before we jump ahead. 10.1.1, let's call this 10. 10.1.1, 11. Okay, this is on a different network, but let's label these right now and give them IP addresses. 14.10. Okay. Whenever you're configuring the IP, 10.1.1.10. Life pro tip, just go ahead and copy that. You're going to need it. Same thing here, except it's going to be 11. Okay, do the same thing on these. 16. This one's going to be 10. Subnet mask. Correct it. And because we're going through that router, default gateway is going to be 1. This is 1. So our PC should be configured now. Now we just need to mess with the serial interfaces on all the routers. So we're going to just swap interfaces. You can look and see right there. Interface. So we're on the Lafayette router. You can see it right there too. Serial 0/0/0. Now, same idea, except we got a different CIDR notation, so the subnet mask is going to be different. We're going to go with 45.20.1.1, 255, 255, 255, 252. No shut. Do right. That should be correct for this moment. We're going to go with that. So keep in mind we assign this to 45 and 1. We go to here to the ISP's router. Enable conf t interface serial 0/0/0. IP address 45.20.1.2, because 1 is already taken up. 255, 255, 255, 252. No shut. Do, and then that should be fine for this moment. You can do the same thing from here. Honestly, you can do everything from this route, set it up. I'm just trying to do it step by step. So interface serial 0/0. Same idea, just with a different IP, because we've already taken up 1, 2, and 3. We're going to start with 4 is the network, and 5 and 6 are going to be our devices. So considering this is the NY one, I'd prefer to just name that one 5 and make the ISP 6 IP address. And that is going to be, I'm blind, 420.1. This one's 5, 255, 255, 255, 252. No shut. Do, right. Okay. So it's configured on the New York side. Now we got to change this. Go to interface serial 0/0/. So it's to the New York one, IP address 45.20.1, and we know that the ISP is this one is going to be 6. 255. We already said that. No shut. Alright. Now, see, everything looks connected. The only problem is that if you tried to ping, I'm not going to show you, but just to explain. If you tried to ping from here to here, everything's linked up and has an active connection. The only issue is that as far as Lafayette's concerned, it has no way of knowing how to actually connect to this through it doesn't even have a way of knowing how to connect to the ISP. So that's where the IP route command comes in handy. Exit. So we're in global config. We're going to do IP route. So we're trying to connect to anything. So we're doing 0.0.0.0. We want to connect to anything. That's what that means. And the way we're going to connect through that is 45, 20, 1, and then it's going to be IP of the router. So it's going to be 2. That's the only route you need to do for the Lafayette router, because as far as the Lafayette router is concerned, it has one connection with the outside world. So the ISP, that's the only thing it's concerned about. That's why we go with 0, all these zeros, and then the IP address we have assigned for the ISP on this router. Now, we got to do it on the other half to just keep it going step by step. We exit this IP route. Just going to do the inverse. So we're going to do zeros because we want to connect to anything from the New York to the ISP. 20, 1, and we assign the ISP on this link to 6. So we do that. And now we need to... So now Lafayette and New York are able to communicate with the ISP, but the ISP doesn't necessarily know how to make the connection between itself, or rather, how does it connect New York to Lafayette and vice versa. So we need to make IP routes on it. IP route, we want to connect, let's say, New York to Lafayette first. We know the local area network, or like the LAN, the network address for New York is this. So we're going to pop in 16. I'm doing it in reverse. Let's go from New York to Lafayette. I'm sorry, having a brain fart. So we're gonna pop in the destination first. So we're trying to go from New York to Lafayette. Benjamin. So we're putting in the actual IP of the network itself, not the router or anything. We want this network to be accessible. That's why we're routing to it. The ISP knows this IP. It needs to know about this network. So we're making it able to understand this route via this subnet mask, which is going to be the 255.255.0. And the route it's taking, let's make sure I don't do this wrong. If I make a mistake, that's okay. We're going to fix it. But if I'm not mistaken, it's taken via this route because we've already established those IPs. It's going to be 45.20.1.1. This router, we assigned it to have 1. And on this, for as these interfaces, this is 2. So we're going to go ahead and route that. Now we need to do the same thing, but in reverse. We're going to route Lafayette to New York. IP route. We want to get to their network. So we're going to pop in their networks. 16.20.14.0. 255.255.255.0. And we're going to do it via this router, which we assigned 45, 20, 1, and 5. Now, I might be mistaken, but I think that should be it. So go ahead and command prompt ping. Let's just do something basic. Ping 10, 1, 1, 11. Alright, beautiful. We can connect to something on the same network. Let's ping across the country. 16, 20, 14, 11. Now, whenever I did this myself, I did have it time out at first, but then it started to work, which it looks like it's about to do again. Nope. I messed up. We're going to save this. I'm going to open up my example. And we're going to look at this is a good way to troubleshoot. Alright, enable. Show IP route. So, statically set. I got it reversed. I think I know the error. Alright, you see how it shows nothing's connected? Let's go ahead and fix that. Having a brain fart. So you see the error that popped up, it would be via 5 then. And if that's 5, this would be 1. Oops. .1.1.0. See if that fixed it. There we go, a reply. So the mess up I had there to explain and how I figured it out. Okay, when we were setting up the static IP routes for the ISP router, the last 2 commands I made show everything, honestly. When you want to reach, for example, this is this network. This is Lafayette to New York. So we want to reach New York via this. This is the IP we want to get to. This is a subnet. And that's the way we want to get to. So it'd be 5. I guess the whole thing I'm trying to get at is you just need to make static IP routes, keeping in mind, okay, this network needs to connect to this network via this IP address. And this network wants to connect to this network via this IP address.